Hello everyone, myself Sandeep Kaur, lecturer chemistry from School of Eminence Mall Road Amritsar. Today I am here to give my representation on position of hydrogen in the periodic table, isotopes of hydrogen, sources of hard and soft water, and how to get rid of temporary and permanent hardness of water. Now, hydrogen with atomic number 1 and mass number 1.008 is most abundant element in the universe, constituting 75% of all normal matter. What is the position of hydrogen in the periodic table? Now hydrogen, we know that hydrogen is placed in the top of the periodic table, and hydrogen is the first element of the periodic table having atomic number 1, which means that it has only one electron and one proton, which means it is having one electron present in the outermost shell. Now, the placement of elements in the periodic table is based on only in their electronic configuration. This structure is similar to the alkali metals, because we know that alkali metal have ns1 configuration, which means hydrogen has one electron in the outermost shell, so it will come first in the alkali metals. It can attain the noble gas configuration of helium by accepting one electron. Now the character of the hydrogen is also similar to the halogen family, having electronic configuration ns2 np5, which is only short of one electron. By gaining one electron, it can attain the octet. It can complete the octet of electrons in their shells, and can resemble the nearest noble gas configurations. When hydrogen loses an electron, it always forms a cation, and in this property of hydrogen resembles with alkali metals, and when it gains an electron, it becomes uninegative. It shows the similarity to halogens. As halogens are electronegative, they gain one electron and achieve nearest noble gas configuration. Similarly, hydrogen completes its duplet and resembles helium by gaining one electron. Now this figure is a representation of single hydrogen atom versus the hydrogen molecule. In a single hydrogen atom, we have only one proton and one electron, and in a hydrogen molecule, we have two protons and two electrons, and two electrons are shown by sharing with the two atoms, and hydrogen gas is formed. Now this is the periodic table of elements. Now hydrogen is shown in the top of the periodic table with alkali metals. So having electronic configuration 1s1. So it resembles with alkali metals. So it is placed here. Now the big question by the scientist is to place the hydrogen in the periodic table, but it is placed along with alkali metals having electronic configuration ns1. Now the isotopes of hydrogen, first protium, which is called hydrogen, having atomic number 1 and mass number 1 with one electron and one proton. Second is deuterium, that is called heavy hydrogen, having atomic number 1 and mass number 2 with one electron, one proton and one neutron. Third is tritium, which is having atomic number 1 and mass number 3, one electron, one proton and two neutrons. Protium, hydrogen, it is the most commonly available isotope. It constitutes 99% of the total hydrogen available in the nature. The molecule of ordinary hydrogen is diatomic. The nucleus of the atom consists of single proton with no neutron and one electron. It has mass number 1, atomic number is equal to 1, and it is represented by 1H1. Second hydrogen isotope is deuterium. It is also called heavy hydrogen. D, it is represented by D. Deuterium constitutes 0.016% of total hydrogen occurring in nature. The molecule of deuterium or heavy hydrogen is diatomic D2. The nucleus of the atom consists of single proton and a neutron. Mass number is equal to 2. It is represented by 1H2. Now the third isotope is tritium. It is formed in upper atmosphere by certain nuclear reaction included by cosmic rays. It constitutes 1 part in 1021 parts of total hydrogen available in nature. The molecule of tritium is diatomic T2, similar to D2. The nucleus of the atom consists of single proton and two neutron. Mass number is equal to 3. It is represented by 1H3. It has one atomic number having one proton, one electron, and neutrons are 2. Now, our next topic is hard water and soft water. We will discuss about it. Groundwater dissolves rocks and minerals, releasing calcium, magnesium, and other ions that causes water to be hard. These dissolved ions give hard water its characteristics. Generally, hardness of water is defined as measure of the capacity of water to precipitate soap. That is the capacity of water to form lather with soap. Hard water forms scum, precipitate with soap. Soap containing sodium stearate reacts with hard water to precipitate out calcium magnesium stearate. It is therefore unsuitable for laundry. It is harmful for boilers as well because of deposition of salts in the form of scale. This reduces the efficiency of the boiler also. Hard water contains dissolved minerals like calcium, magnesium, iron in the form of ferric, sulfate, etc. The degree of hardness is measured in parts per million ppm or grams per gallon (gpg). Hard water is better for drinking because it contains minerals. Soft water is better for cleaning because it doesn't form scum with soap. This picture shows that hard water is unsuitable for laundry purposes that it forms scaling in the pipes. Therefore, if we use hard water in turbines and heat exchangers, their pipes will be corroded. Now we will discuss hard water in the health point of view. Hard water, when used for drinking for long period of time, can lead to stomach disorders. Especially hard water contains magnesium sulfate salt, which can weaken the stomach permanently. Now, before discussing about the purification of hard water, we will discuss again the sources of soft water and hard water. Soft water, it lathers with the soap, and which is obtained from rainwater is called soft water. The water is suitable for household purposes, for example laundry and cleaning. Hard water, it is known as hard water because of the presence of calcium and magnesium salts. Hard water does not lather with soap but instead forms a precipitate or scum. The hardness of water is a measure of total concentration of the calcium and magnesium ions expressed as calcium carbonate. Now there are two types of hardness. Number one is temporary hardness and number two is permanent hardness. Temporary hardness is always due to the dissolved salts of bicarbonates, hydrogen carbonate, and magnesium hydrogen carbonate, and it can be removed by boiling. By boiling these salts, as calcium hydrogen carbonate gives calcium carbonate plus carbon dioxide plus water. Similarly, magnesium hydrogen carbonate will give you magnesium carbonate plus carbon dioxide plus water. And then permanent hardness of water is always due to the presence of chlorides, sulfates of calcium and magnesium. This type of hardness cannot be removed by simple boiling process. Now the removal of hardness of water temporarily. First process is by boiling. Soluble bicarbonates are converted into insoluble carbonates which are removed by filtration. Reactions हैं, calcium hydrogen carbonate will give you calcium carbonate plus water plus carbon dioxide. Similarly, magnesium hydrogen carbonate will give you magnesium carbonate plus water plus carbon dioxide. Number 2 process is by Clark's method. Calcium hydroxide is Clark's reagent. It removes the hardness of water by converting bicarbonates into carbonate. The reaction is calcium hydroxide plus calcium hydrogen carbonate will give you calcium carbonate plus water. Now, how to remove permanent hardness of water? Number 1 process is Gans permutate method. In this method, sodium aluminium orthosilicate Na2Al2Si2O8, which is also called zeolite, is used to remove the permanent hardness of water. The reaction is Na2Al2Si2O8 with X molecules of water plus calcium 2 ions gives 2 sodium plus calcium aluminium silicate X water. Second is Calgon's process. In this method, sodium hexametaphosphate, which may be Na6P6O18 or NaPO3 6, known as Calgon, is used. The hardness of water is removed by the adsorption of calcium and magnesium ions. Now, how to remove permanent hardness of water? This is the ion exchange resin method. In this method, permanent hardness of water is removed by using resins, calcium, magnesium ions, which are exchanged with chloride and sulfate ions, are exchanged with anion exchange resin, alkyl hydroxylamine. Demineralized water is formed in this process. First of all, carboxylic acid plus calcium ions will give you calcium acetate plus H positive ions. Then alkyl hydroxylamine plus chloride ions will give you alkyl amine chloride plus hydroxyl ions. Then these H positive and OH ions will combine to form demineralized water. This picture shows the reactions which I already discussed in the previous slide. In this, H positive and OH ions forms demineralized water. Now we will discuss the summary that hard water contains calcium ions and magnesium ions in the aqueous form, and these ions react with soap, making it difficult to form leather and producing scum. Hard water can be softened by adding calcium hydroxide, which makes insoluble carbonates, which are separated by filtration. Alternatively, the hard water can be passed through an ion exchange resin. In a column, sodium ions replace the calcium ions in water as it passes through the column. Now, students, we will discuss about MCQs. Number 1, the hardness of water is due to the pair of ions. Which pair of ion causes the hardness of water? First is calcium and potassium. Second is magnesium and potassium. Third is calcium and magnesium. And fourth is barium and zinc. Among these, we have discussed C is the right answer, calcium and magnesium ions. The second question is, which of the following statements about hydrogen is incorrect? A. Hydronium ion H3O positive exists freely in solution. Second, dihydrogen does not act as reducing agent. Third, hydrogen has 3 isotopes of which tritium is the most common. D. Hydrogen never act as cations in ionic salts. अगर हम देखें तो पहली ए वाली, बी वाली और डी वाली, ए वाली ठीक है, डी वाली भी ठीक लगती है, तो हमें बी और सी वाली जो है वो इनकरेक्ट है. डाईहाइड्रोजन डज नॉट एक्ट एज रिड्यूसिंग एजेंट एंड हाइड्रोजन हैज़ 3 isotopes of which tritium is the most common. We know that protium is the most common. Now the question 3 is, nascent hydrogen consists of number 1, hydrogen atoms with excess energy, hydrogen molecules with excess energy, hydrogen ions within the excited state, and solvated protons. Nascent hydrogen जो होता है वो हाइड्रोजन आयंस विद इन द एक्साइटेड स्टेट. नो, ये नहीं होगा. हाइड्रोजन मॉलिक्यूल्स भी नहीं होगा. तो हाइड्रोजन एटम्स विद एक्सेस एनर्जी होगा फर्स्ट आंसर. Next, fourth question. Water softening by Clax process uses number one, calcium bicarbonate, sodium bicarbonate, potassium, calcium hydroxide. So fourth, D is the right answer. Calcium hydroxide is used for water softening by Clax process. Now, the fifth question. The softening of hard water by synthetic ion exchange resins is based upon in number first one, increasing the lattice energy, physical separation, lowering in the activation energy, D, exchange of cations and anions. The right answer is D, the exchange of cations and anions. Sixth question is a water softening reagent among the following is it is clear that it is answer number C, sodium metaphosphate. Na6P6O18 is the right answer.